This is Greg Troutwine with Marine Technology TV, and we're very pleased to be joined today by Chris Hearn, Director of Marine Simulation at Memorial University in St. Newfoundland and Labrador, Canada. Chris, we've known each other, as we just discussed, for a number of years. But to start us off, can you give us a personal, professional background with insights on your role as the Director of Center of Simulation?
Good to be here with you, Greg. Yeah, so I'm the director here. By background, I'm an alumni. I'm a graduate of the Marine Institute here at the Memorial University. Came through the nautical science program, from third mate right through to captain. Sailed both domestically and foreign going. Sailed under different flag states. Everything from ships operating in the Arctic through tankers right through to cable laying and repair ships. So I did a lot of stuff there. I came ashore first as Marine superintendent and designated person ashore, which was very interesting in that, when you're on board, the old joke is when you're on board the ship and you're dealing with things at a specific and operational level, you're always wondering, why are we doing this? And don't they realize what's going on? And, how can I make this actually work? And when you're actually on the other side of that and you're in the office and you're on shore and you're dealing with all the other sides, you get to see a whole other piece to what's actually going on in the company and where the margins are, why the decisions are being made. But also, interestingly for me, it also put me in touch with the classification societies, again, at a different level, apart from when they just show up to the ship with their white helmet. But dealing with them on planning and projects and dealing with the flag state authorities and all these sorts of things. So that was all very interesting. But it also gave me insights into, the possibilities that, particularly when it came to training and obtaining training for our companies and the companies I was working with and for the fleet. And so I had this kind of nascent interest in how we could be doing things. And particularly coming from Newfoundland, I can tell you there was nothing worse than getting off the ship and trying to make your way home, only be diverted to go fly somewhere to go do training, even though the institute was there and it was certainly set up to be able to do some of this. And so when an opportunity came for a change, and I did come back to the institute to take over here as the director at the center, I had this mindset that we can do anything that anybody can do in terms of training and simulation at our facility. Nobody needs to leave here. In fact, people can come here to obtain training. There was certainly an investment made very early in the institute to create the center, and that was very forward-looking at the time to create it, like the initial investment that set up the facility and the technology. And so I saw the opportunity to leverage that into more special type applications that really reflected the operating conditions that we face here in Newfoundland in terms of harsh environment, the challenging conditions, and how people react in really high stressful situations. And so I kind of brought all those things in my background, the experiences, the different places I've worked, to combine with what I saw as the opportunity to leverage those investments that were made to stand up the center, to kind of move us into more newer areas or to capitalize on things that I thought would be a really good idea. And it's worked out so far.
So, looking from that time and today, can you just give me a by the numbers look at the marine simulation using the metrics of your choice?
Yeah, that's a really good question, Greg. So we have several metrics. The Institute, our parent organization, is an ISO qualified entity, and which makes it unique in terms of training and education institutions. There's not many that have that, at least not in our region. So that has very specific requirements and metrics that we use. We track the feedback from the people who are attending the various courses or short courses in our facility. We track their feedback and their outlook on our technology and our equipment, how it was used, how it was utilized, and also the instructors that we have, our faculty members inside the center. And I also look at like our total utilization and things like that. And I'm really pleased to say it all scores very high. So like it really from 1 to 5 is the ranking. And I had to look back through because we monitor these numbers. On average, we score about 4.5 out of 5, right across the board. And interestingly enough, even though we do have a lot of unique technology here, which it's a full-time job to keep that operational and up to date. I can tell you, and we have some really good people here who do a really lot of hard work to do that. Is the instructors always consistently rank the highest? So it's their anecdotes and their feedback and their ability to work with clients or people who are doing training and provide that interactive piece. And it's how they use the technology that's really compelling. Like anybody who comes through here, I always say, like anybody with careful application of time and money can buy all this stuff, but it's how people use it and how they overcome, the shortcomings and things that are inherent to simulation to make it more compelling, which is really good. So I'm really pleased with that. We, as I said, we keep a really close eye on that. The wash-up meetings we have here weekly to go through how everything went and get feedback, how we make changes to our technology or how we deliver things. We're very transparent about all that. So that's all really, really good. The numbers in terms of how many people come through the center, it varies really year by year. Anywhere from 300 to 350 people per year is kind of an average number for us. Again, our class sizes are generally tend to be very small, anywhere from 4 to a maximum of 8, except for some of the things that we've started to do online. And so that kind of keeps the numbers a little bit small. That doesn't include projects. So companies coming to do work with our facility or to rent the facility to do work. We don't count them normally as part of some of the training output, but in a really good year where we have a lot of things going on, it can be over 400 people come through. So that's a good metric. Some might say that's a bit small, but for our facility, given what we're doing, that's a pretty good number. So, and I can also say, again, reflecting on the technology aspects, I track very carefully the downtime in terms of interruptions of service and these sorts of things. And again, really a reflection of the good people that we have and their dedication. That's very minimal. We can have 4 or 5 different courses or different things going on all at the same time, and very minimal interruption in what it is we're doing, considering it's so heavy on the application of simulation that, again, it's a reflection of the good technology we have, but also the hard work of the people.
You have been here the head of this at a very interesting period, and in step with the evolution of power and speed. Simulation technology has certainly come a long way since you started in this position. So just, can you broadly categorize changes that you've seen in maritime simulation in 10 to 15 years, putting in perspective how that specifically has impacted your ability to train mariners?
Yeah, you're right, Greg. So I came in 2008. Like there's been several, I would say, milestones or waypoints, more appropriately, I suppose, in the maritime context, in terms of improvements that I've seen since I've come into here. And vendors, simulation vendors, technology vendors are generally a lot of similarity between them all. What it is that they're delivering and their customer service and these sorts of things. So there's a lot of parity there. You have some new people coming from the gaming technology and gaming background, because they've seen this opportunity now to bring some of the really interesting stuff that they're capable of doing, again, more focused on the visual attributes, into the hardcore kind of heavy duty math based simulation side of things. And so I would say to you, like in my time here, I've certainly seen a definite improvement in the visual engines that people are using, again, echoing this opening of competition of the gaming people coming into the marine simulation industry, like to make the visuals much more rich and much more realistic, like the cloud shadowing and the way the water curls and these sorts of things. Again, that's not lost on people who are actually in the simulators, because again, we're looking to establish presence, the fact that somebody really believes they're in the simulation, because that's where the best action takes place. I can also say that the improvements in the fidelity of the modeling of ships, the modeling tools themselves, has really dramatically increased. The ability to produce fully 3D models is quite a powerful thing. Like normally in former years, in order to have different versions of a ship, you would have to build different versions at different drafts of ships. Now we have the ability to build a one 3D hull and include the tanks and be able to adjust fluid levels in the tank, and then of course be able to adjust the trim and draft. That's a very powerful tool because it reduces the amount of ships you actually have to build, but it also improves the fidelity of the ship you are building. Now it's much more involved. It's a very complicated process, and the models are very complex to build. But again, in terms of utilization in different types of applications, I must say that that's really something that's dramatically increasing and improving what it is that we would do. Also the instructor stations and the platforms that they're running the simulators as well. Like what you can do now as opposed to what you could do when I came in 2008, tremendous amount of difference now. Like the fidelity of controls that the instructors have to adjust, like even something as simple as daylight, like, and to make nuanced changes that would reflect what people would actually see, and be able to interact closer inside the model itself is much better. Like to have the ability to swing and maneuver cranes and ship's equipment that people would actually be expected to use on board, that's very tremendous as well. And the interaction or the interoperability of simulators with one another in a facility, or even to be able to connect to a facility remotely, is very interesting as well. Like again, it's a long list to be honest about what I've seen in my time in terms of improvement, and that really reflects the vendors, whether they be smaller, very niche vendors, or very large, you know, the big, like the Coke or Pepsi people, like the big simulation vendors, them really recognizing that their clients are pushing back. They're getting a lot of feedback from people. We want to see this. We need to see that. And also the fact that they've also recognized that they can distribute simulation now. They can do simulation on the cloud. The engine is essentially on the cloud, and you can pull data down to a laptop and have a very good high fidelity simulation. That was unheard of, you know, 10 or 15 years ago, but it's there now, which makes it a much more distributed system. So you and I can be here pulling a simulation event out of the cloud to run on our laptops and be in kind of the same scenario. So that's pretty profound.
When I would, because when I did visit the simulation center again last, I was really by the size and the size, the scope, and the interconnectivity kept going on. So just in the round, can you discuss major pieces of your simulation center with insights, which you've already discussed in brief, but you use them separately or in tandem to maximize the efficiency and effectiveness of a training?
Yeah, sure. No problem, Greg. The center consists, you know, there's groupings of technology. Like by sheer number, yes, there's a lot of equipment, which you know, I won't list them all out. But essentially, the center, its main focus is around 3 Class A ships bridges, full motion bridge, the offshore operation simulator, and the other one we call the Heritage Bridge. So the big full motion, which you were on, and the offshore simulator are both sitting on these 6-degree motion beds. So that enables when we build a ship model here and we have it in an operating environment, it moves just like the ship will move, whether it's in, you know, storm on the Grand Banks or you're battering your way through Lancaster Sound and ice. Everything is replicated there. And then there's the Heritage Bridge, which is very specialized towards the shuttle tankers, which serve the offshore. So these big 3 bridges are all connected, interconnected. And then we can also connect to our propulsion plant. We have a full mission engine room simulator, which was where the engineers spend their time. Additional to that, and the original first big simulator that was in CMS is the ballast control, a full mission ballast control simulator for an offshore drilling rig. And that sits on a motion base as well, and it responds to operator input. And then we move out to outside of that core to, we have all kinds of dynamic positioning equipment. Then we have 4 part task ships bridges, and then there's ECDIS and GMDSS. So there's a lot of technology there when we expand outside. Pulling back to our core, yeah, so we can run, you know, several courses all at the same time using all the different simulators, and we do. There's actually several groups here now doing several things. But one of the unique things about that interoperability, that connectivity, is that we do run large multi-party exercises all in the same scenario. And this really shows up when we're doing these big tow-out projects. And so the structures that sit offshore here in the Newfoundland energy industry, these are built here and then they're towed out and installed on the fields. So the operators and the people that are involved in that operation will come to our facility, and we'll have all the bridges with different groups on them, all in the same scenario, under direction, all doing something at the same time. Ship to ship operations, which is something else we do, where tankers come alongside one another to load. Again, utilizes multiple bridges, 2 of the tankers plus the tugs that are involved. And we'll have people on the different bridges, and then we can connect the engine room to have the engineers involved in the scenario. So that's a kind of a snapshot of both single courses, whether it be polar navigation, advanced or basic, or BRM or dynamic positioning, all can take place on different bridges, or we can do a project where you have all the parties all at the same time in the facility. So there's a snapshot of all the usage.
From where you sit, what mega trends do you see that are significantly impacting the maritime industry? And then how is the university and the simulation center investing to ensure that you're ready to meet that change that's coming?
Yeah, as you referenced earlier on, Greg, about AI. I think artificial intelligence is certainly winding its way through. It's certainly on land, and it's certainly in like the data preparation for weather forecasting or hydrography, or these sorts of things. That's starting to make its way into the maritime industry, even in the freight forwarding and in the chartering business. I think. Well, maybe I'll just list them out and we'll get into them. So AI, definitely, how that's going to play its piece on shipping. I think autonomy, increased use of autonomy, whether it be maritime autonomous surface ship or ASV, autonomous surface vessel, however you want to call them. The maritime cybersecurity piece, which I think is the gorilla in the room, based on those 2 previous ones. And of course, then I think how the industry is going to deal with utilizing and deploying new fuel systems and all the preparation and requirements for that. And of course, sitting over the top of all those things, those 4 things, is the skills and competency for the people on board the ship. So with AI, finding its way, how it's going to be used and when it's going to be used. Like, does AI assist with collision avoidance? Does AI assist with cargo preparation and cargo loading? Does AI work with weather routing and navigation or voyage planning? So how do those things actually look? Where is the AI sitting to? Is it on board the ship? Is it a tool, or is it almost like, another crew member, not under articles, but it's there to be used? So I'm very interested to see how that plays out. Again, if you have simulators, you can actually trial this sort of thing. We can experiment. And of course, that lends into, well, if eventually we get to a point where it is deployed and it is sanctioned for use on board, and the IMO gets on board and all these sorts of things, how do people be trained in a bridge team scenario where this thing is also part of that? When it comes to autonomy, there is autonomy on board. The good old autopilot, of course, is autonomy 101, and unmanned engine rooms and these sorts of things. Now, I will go on the record and say, of course, I am absolutely not advocating for replacement of people on board the ships, and I don't think that'll happen realistically. We may get to a point where you have a combined scenario where we have the smaller mass operating in areas where there is people on board ships. I think that's the more likely scenario. But autonomy is present and it is growing. And so at our institute here at the Marine Institute, we're interested in how autonomy is played out in terms of remote operations, very dense traffic scenarios and situations where you may have this mixture of both vessels that are either remotely controlled or autonomous, interacting with crewed vessels. And of course, pilotage. How does remote pilotage work? How do you deal with a mast that's operating or coming into an area where there is mandatory pilotage? Is there some sort of a handover to people sitting in a control center now in the region where they take control? And so our institute is setting up an autonomous test zone at one of our facilities. And inside of that, it'll be a kind of a sandbox or a playground, which will include the Marine Institute now has an autonomous surface vehicle. And so I'm interested to see if we can connect one of our big Class A's to that autonomous vessel, which would be a very interesting technology challenge, but also quite a feat, because I'm curious to see, does the mass drive the visual and the operating system for the simulator, or does the simulator do it for the mass? I'm curious to see how that connection works, because that brings forward all kinds of opportunities then to look at, again, remote pilotage, situational awareness, and again, collision avoidance scenarios. Coming around to the maritime cybersecurity, again, I think this is an enormous challenge. We're now pushing information technology, with all the good and bad that comes with it, into operating systems. As I said to somebody the other day, a rudder angle indicator doesn't care where the information is coming from. Its job is just to report what the rudder is doing. And so if you're tampering or doing something with that as a part of a cybersecurity incident, then it's just going to take the information and it's going to tell the rudder to do this. And so we're interested to see how training is involved for that. So the initial, be safe about what's coming on board and downloading things, or even jump drives, what supplier is coming on board and what are they plugging into, to looking at how you identify and counteract a maritime cybersecurity event on board a ship in a really critical scenario. So using the simulators as part of that training to allow people to experience that, I think, is a really interesting opportunity. So we're kind of playing our way into this bigger thing around cybersecurity, maritime cybersecurity, and how we can participate with other agencies or entities in training there. When it comes to fuel, and the transition to different types of fuel systems, again, for the propulsion plant, for the marine engineering program here, how they deal with switchover and changeover from fuel sources, how the preparation affects like power management on board the ship, and that interconnection between what the bridge is asking to have done and what the propulsion plant needs to do. And so adding components or new engine models that can represent whether it be ammonia or hydrogen or combination fuels, how that works. And again, to sum it up overall, that how do the skills of the people who are coming into the industry now, how do their training need to be changed? Or the maritime education piece, like the institute would do here at the School of Maritime Studies, what do they need to have? How does simulation now probably take a much more stronger and involved role from day one of year one right all the way through to their fourth year and when they graduate? How much more simulation is now required, necessary? But also for the people who are in the industry now. And I think this is something that people are not thinking about when they're talking about, increased of all these other things. There's people who've been in the industry and on board ships now for quite some period of time. Their ability to adapt and their ability to utilize these new technologies with their own skill sets, because they came through a much more different scenario and a system and a preparation, and their experiences taught them all these things. And now we're going to slowly start to push, I hope, very slowly and measured format, new ways of doing and thinking on board, which includes possibly working with AI or all these other considerations. We need to take a very measured step into how we introduce these people and get the best of their skill sets, but also their experience. So I think that, to sum up, we're certainly cognizant and preparing our facility here. It's a continuous job to always make sure technology is ready to go at all times. And we're kind of aiming to look to that future, how we're able to supply the means to deliver that kind of training.
I'm just going to change the tone a little bit here, because like I said, John's Newfoundland and Labrador, and I often have just explained to people the unique connections that the city and the region have in the offshore industry. It truly is a unique collaborative community that you have up there. So can you put perspective when you look around you, all the assets, the organizations, technologies, both inside the university and out, and that help you achieve your mission more effectively?
Yeah. Again, another great question, Greg. So, like, our role, I guess to start off by saying that, yeah, so our center is part of the institute, which is part of the university, which is part of this cluster of all this technology and capacity, the ice and wave tanks at the NRC, and all the other technology, and then of course an oil industry, an offshore energy industry that's taking place in really challenging conditions, and a long history, very long, because we're an island, long history of maritime trade, and of course from the fishery right through to what we have now. So we have this in our DNA. It's part of what we are. And so there's this connectivity between all these different entities. And what has happened is that we've grown this tech sector primarily focused on, again, the maritime and oceans industries because we needed to. There was opportunities to grow it here because a lot of technology that was available or even wasn't available, again, didn't reflect or couldn't deal with a lot of the operational challenges, the reality of the conditions that we have, this mixture of weather and ice and sea state and isolation and variability and quick change in the weather patterns here and all this kind of stuff. So it assisted the growth of all that. We had a provincial government that recognized that very early. But I'd also suggest that it really, again, it reflects life here. We are innovative by nature because we had to be. I heard a great quote one time about Newfoundland that it has a landscape that makes you want to live up to it, but it doesn't provide you the resources to do it. And so we've had over 500 or 600 years of living here. Because we're isolated, we've had to grow something here in order to be able to deal with things. And that, even though people think about Newfoundland, don't think about technology, it's very much, and this goes back a long way, of being innovative around how to do things. And also this connectivity to one another, like, the companies that grow out of research projects that are either at the university or here at the institute, whether they be in the ocean tech or whether they be in fisheries and resource gathering, or they're in maritime or offshore. So radar systems that are able to be, to do an amazing job in ice, like Rudder's radar systems, again, how those came out of projects and then grew into companies that are now very successful and doing work all over the world. And so you have this self-sustaining circle of the education and training pieces, like we would do here at the institute or at the university, spilling out these really bright minds of these people who are working with the industry and see a really good idea and say, I got to do that. Of course, to support all that is you have the cluster groups like Oceans Advance and the other technology groups, TechNL, and these other associations that are really blowing air into this fire that's growing here all the time for the tech sector. And so, yeah, it's this combination of the need to do it and the want to do it that kind of sustains it, in a very, very isolated place and with a small population. So I think those are that's a nursery ground for innovation and need, is that we had to do it. Like, we're not that far away from North America, but I'm telling you, we're far enough that, it's trouble enough to get here. And so that kind of drives a spirit of, let's find a way to do this.
I know in your job, it's not possible to always name names. Give insight on a recent training group that's run through your facility, a group you saw that had a unique request or a scenario that you and your team were able to fulfill, given the offer of your simulation center and the depth and breadth of the Memorial University.
Yeah, I can't name names. Our clientele is very varied. It's pretty wide. It can be, the companies that are doing work here. It can be companies abroad. It's not a recent one, but I can tell you an example of an interesting challenge that required us to reach outside of our own facility and into the cluster here, into the community. We did a very interesting project. They came back because obviously they liked it because we did 2 runs with them. So a few years ago, you might remember, there was a cruise ship that actually went through the Northwest Passage. Over 1,000 people on a cruise ship. This is quite a thing. And so they came here to prepare for that voyage. For the bridge team, the captains and the senior officers came here, and so we had modeled certain parts of the Arctic already for our own work, and they wanted to come here to prepare for contingencies. Like, they did an enormous amount of planning. I mean, this was not lightly done, and it took quite a number of years. And I really gained respect for their project management team because they were very practical, pragmatic people about what they were going to do. And so as part of that, of course, we had a ship, and we took them through and all that stuff. But we reached out into the community to provide additional training and resources for them to be able to prepare for their voyage. Again, we reached out to Rudder for their ice radar systems, and that gave them additional training capabilities because they were installing the systems on board. There were all kinds of other environmental people to provide insights in terms of conditions and patterns and weather patterns and all these sorts of things. So put that all together, that was a really interesting experience. And they left here very happy in terms of what they came to do. You know, we ticked the box of not only providing training, but they were pleased with what they learned because they came in here with no foreknowledge about the conditions or the scenarios they would get into. And when they left here at the end of it, they were much better prepared.